Greetings everybody, and welcome to example 4 in our series on normal distributions. So what we're given in this problem is that a company has tested a new cellular battery. The mean number of hours that a newly charged battery remains charged is 43 hours with a standard deviation of 5 hours. So we're assuming that the distribution on the number of charged hours will follow a normal distribution. And so we're asked, what is the percentage of batteries that will remain charged for more than 33 hours? So what we're asked in this problem is that we have a normal distribution, and that normal distribution here is doing something like this. We're told that the mean is going to be 43 hours with a standard deviation, sigma of 5 hours. Now, what we want to know is that what percentage of batteries will remain charged more than 33 hours. So we have an x value of 33 right here. And so what we want to know then is what is the area under this curve that's going to be above 33 hours. Well, we can figure that out by transferring these or going back to our benchmark of the standard normal distribution. And so with the standard normal distribution, we have a distribution that's symmetric around the y-axis, and we have a standard deviation of 1 in this case. And so what we want to know is what is the z-score that's going to correspond to our x value of 33. Well, for that, we have our formula that z is going to be equal to x minus our mean divided by our standard deviation. And so in this case, we have our x value of 33, our mean is 43, and the standard deviation for our non-standard distribution is going to be 5. And so this actually gives us a z value of negative 10 over 5, or a z value of negative 2. And so over here on our standard normal distribution, we have a z value of negative 2. So kind of transferring these kind of area problems, what we then want is what is the area above the z-score of 72. So for this particular area, we can break it up into kind of looking at it as two separate areas. One area where we are in between negative 2 and the y-axis, and then a second area where we are just going to be to the right of the y-axis. Well, for our standard normal distribution, we know that because we're symmetric around the y-axis, the area here is just going to be 0.5, because our total area underneath the curve is going to be 1. And so half of that's going to be 0.5. Now, for our area, so if we mark that over here on this side, so for this area, we've got an area of 0.5. Then for our area in between negative 2 and the y-axis, we can use kind of symmetry arguments and see that if we look at the area in between the y-axis and the value of 2, that area is going to be exactly the same as the area between the y-axis and negative 2. Well, coming back up to our table, here we see that for a value of 2, that area is going to be 0.477, which means that the area here will also be 0.477. So our area on this side of the y-axis is going to be 0.477. So our total area is going to be those two areas added together, So 0.477 plus 0.5 gives us 0.977, or 97.7%. And this gives us our number of batteries that will exceed a value of 33 hours. So I hope you've enjoyed this video, and I will see you guys in the next problem. Take care.